right, today we're going to be working with section 3.7, which talks about graphing rational functions. Let's talk about a little bit real quick. What is a rational function? So rational functions is basically fractions with variables. If you want to go, very broad terms. So basically to have a rational function is, and we're going to be talking today about what happens when there's a variable in the denominator. So before now, we've been talking about something we've kind of been looking more, I guess it'd be like here. We've been talking how to do simple rational functions. So we've been talking about rational functions, but we've kept them simple, saying that there's never going to be divided by a variable. Now we're going to say, how can we go and do all rational functions? So when we were talking about finding that min and that max, that was more on how do we graph when we know we don't have a variable in a denominator. Now we're going to be like, okay, what's my plan of attack if I do have a variable in the denominator? So what we're going to be looking at is I just wanted to start by showing you what does it look like when we graph here and we have a rational function. I wanted to show you kind of how these rational functions. So here's my function. I'm just highlighting because I know it's kind of hard to see. Here's a function here. And right here what I'm highlighting is I was highlighting, actually, let me see if I can do that a little bit better. I was highlighting my asymptotes. So let me show you my asymptotes here. They have them highlighted here. So I highlight them here with my purple. And that shows here we had an asymptote, a horizontal and a vertical asymptote. In this problem right here, we have here, sorry, I'm going to move, I got to get out of asymptotes. I forget when I'm doing this. Okay, so here's my asymptote here. I have two vertical asymptotes, and I have, here's another vertical asymptote right here. And I have a horizontal asymptote. So let me give you a horizontal asymptote here. Here's my horizontal asymptote. So we have horizontal and vertical asymptotes. So if you remember what an asymptote is, if we have our little ant here, our ant is going to be on this slide and it's going to keep sliding forever because it's never going to meet that asymptote. It's going to come really close to it but never meet it. I know right here it kind of looks, because of my lines are really thick, it looks like they're going to be like they're going to meet them, but they're not. They're going to come really close to that asymptote line, but you never technically meet it. All right, I guess I have a lot of the, oh, I have the infinite collinear there. Sorry about that. All right, so other vertical asymptotes, I just have some different pictures of some different vertical asymptotes. So I wanted to talk about, we already know how to do it when we don't have a variable in the denominator. This is what we do when we have a variable. So let's look at this. What do we know about a vertical, which is along or up and down, and a horizontal, left and right asymptotes? Okay, so right here, this here is my vertical asymptote. This is my horizontal asymptote, all right, that I have right there. So we have a vertical and a horizontal asymptote. What do we know about the asymptotes in these three different pictures and about the equations? And so I'm actually wanting you to think for a minute, why do you think the equations are different, or how are the equations different? And can we come up for a rule of when we have one horizontal asymptote, no horizontal asymptotes, or one horizontal asymptote and two vertical asymptotes? Like, how do we know when it's going to be each one of those different cases? All right. So I want you to kind of think about that. And really, you might even want to pause the video right now and kind of think about it and come back, maybe have your own theory. What happens in the end is, if you notice in this equation here, in my first equation, I have the numerator and the denominator have the same degree. So this one has the same degree. And when you have the same degree, it means you're going to have one horizontal asymptote and one vertical asymptote. Okay? In number two, or the second equation given here, I don't have the same degree. The numerator degree, numerator, is greater than the denominator degree. Denominator, okay? And what that actually means is there's no horizontal asymptotes. No horizontal asymptotes. Okay? And actually, we're going to find out tomorrow more what that happens. And actually, there's a slant asymptote that's in there. And I know I don't show it right now. We'll find out more about that in our next video. In the third example, our denominator, the bottom, is greater than our numerator for our the exponent, excuse me. So it's the, I'm blanking. Um, So the degree, and the degree is the degree of the highest exponent. So when the denominator is going to be greater than the numerator, what happens is you always get a horizontal asymptote at 0 there. And then a lot of times what you're going to get is you're going to get 2 vertical asymptotes in that category, in that circumstance, okay? Not always, but a lot of times that we're going to have the 2 vertical asymptotes. But that's the difference, and that's the 3 options that we have. Either they're the same degree, both of them are to the first power, second power, third power. Their numerator is higher, and then there's no horizontal asymptote. The denominator is higher, and then the horizontal asymptote automatically is 0. Okay? So now, we're going to go here, and we're going to talk about, for this whole shebang, okay, when we're going to try to solve this, we're going to factor your numerator and your denominator. We have to get really good at our factoring skills. Then we're going to look for any factors that cancel. And anything that cancels results in a whole. And we're going to be talking about what this means when we say we have a whole. It's easier for me to show you visually, all right? So what you want to do is you want to say, okay, for what factored out or what canceled out, what would make that value a 0? And then you want to plug that in, that value into the function, and you want to see what's left after you cancel, okay? Then we have our vertical asymptotes. So we're going to have the up and down asymptotes, the vertical asymptotes, and our horizontal asymptotes. So the vertical asymptotes, you look at what you have in the denominator and you say, what makes my denominator equal to 0? And that is actually what you cannot have for your x, because you can never divide by a 0. And so that makes a vertical asymptotes. We saw that in trigonometry. We said, what can you not have for an x? What can you not take the sine or the cosine of? And actually, it was the secant and the tangent when we were dividing by a 0. And so that's when we found vertical asymptotes before. Then the kind of more involved step is, okay, deciding if you have a horizontal asymptote or not. And then if you do, what kind of an asymptote is it? Okay, sorry about that. Oh, darn. Sorry. Okay, so if the degree of the numerator is 1 higher than the denominator, then there's a slant asymptote, and we're going to do long division. If the degree of the numerator is lower than the denominator, then we have a horizontal asymptote, and that is y equals 0. If the degrees are the same, then we have a horizontal asymptote, and we have to calculate it by looking at the ratios of the leading coefficients. And I'm going to show you some of those examples here in just a minute. And then to wrap up, to complete the graph, we're going to plot 2 points in each sections, and we're kind of looking between vertical asymptotes, on either side of vertical asymptotes, and I'm going to show you how to do that. So I talked about this step 4, I believe it was. Let me look back here real quick. Yep, step 4 where we compared. So let's compare and say, does it have a horizontal asymptote? If so, what is it? Okay, so when I look at my first example here, I'd say yes, it has a horizontal asymptote because the numerator exponent matches the denominator exponent. And then it is the coefficients of that leading exponent. So the horizontal asymptote here is y equals 3/5. In this case, we have the 20 and the 20, so it has the same degree. And then the horizontal asymptote here would be 3/8. So it's the coefficient of the highest exponent. In the last case, since the denominator is higher than my numerator, yes, it does have a horizontal asymptote, and it's at y equals 0. So if I had a problem like this, y equals, let's call it, x to the third plus 2x squared minus 5, and I divided it by x plus 1, okay? Well, this one I can just look at it and say, you know what? It's actually not going to have a horizontal asymptote. It's actually going to have a slant, horizontal, and we'll find more what to do. I just spelled horizontal wrong. Tomorrow, all right? So, or in the next video. So we know we don't have a horizontal asymptote, and that's kind of what I wanted to make the point of there. So let's look at an example here. This is already factored. Our first step was to factor it, and just to make it easier, I wanted to factor one out. And so here, I'm going to get rid of anything that cancels out. When it cancels out, the x plus 2 cancels out, that makes a whole. And the whole exists where x equals where that what's I canceled out would make it a 0. So it's here, it's x equal -2. So it's what makes this grouping symbol right here a 0, and the answer is a -2. Now we look at the degrees next, and you determine, is there a horizontal asymptote or not? And the answer is yes, there's a horizontal asymptote. If there's a horizontal asymptote, it means there can't be a slant. You have to have one or the other. So we do have a horizontal, and we'll talk about, and the coefficients here would be 1 over 1. So the horizontal asymptote is at y equals 1. The last step, and actually this could be the first step a lot of times, is what's your vertical asymptote? Your vertical asymptote is what makes your denominator equal to 0. Well, technically, we don't have to worry about this -2 or the x plus 2 because it's been canceled out. We can kind of assume we've taken it away. And we can kind of assume that what we have now is x minus 3 and x minus 4. Okay? So what we get for horizontal or vertical asymptote here is that x can't be a 4 because if x is a 4, it makes it dividing by 4, and so that makes it does not exist. So when x equals 4, that does not exist. So what you do with this is you say, okay, for my vertical asymptote of x equal 4, 1, 2, 3, 4, I am right here. Okay? All right. There we go. I wanted to extend that. For the horizontal asymptote, I am at y equals 1, so I'm right here. There we go, at y equals 1. So there's my horizontal asymptotes. Now there's a couple options for where the curve it will lie. One option is that the curve kind of comes like this and approaches here, and then on this side too. It's always in opposite kind of quadrants. I know it's really not quadrants, but they're always these two, not those two. So, oh my gosh, everything's moving when it shouldn't be. So let's keep that there. This was at 4. I'll learn how to lock things. All right, this is what I was trying to move. It's either here, but another option is that instead of this being here, all right, another option is that it kind of curves like this or this. So we really don't know where our curves are, and so we have to do some tests that show where do our curves exist. So we have to go through and say, where are our curves? So we don't know for sure where you are yet. I'm going to get rid of my possible curves. And let's do some tests. So I want to test some x values. Someone said, oh, is it like the 0, 0 test? Yes, it's very much like the 0, 0 test. And I'm just going to test the two zones, here, and say, okay, where could I be? So let's look. Let's say what's in the zone that's to the left of my vertical asymptote. And that would be at 0 and at 1. What's in the zone that's to the right of my vertical asymptote? And that might be a 5 and a 7. I'm randomly picking these values. So let's work these out. So now we have some different values. At 0, we found we were at 3/4, so we're right here. At 1, we're at 2/3, a little bit lower. So we kind of can guess our curve is going like this. At 5, 1, 2, 3, 4, 5, I was at 2, 1, 2, so I was here. At 7, I'm at 1.3. So again, we can kind of see it, these curves are kind of paired with each other and kind of act the same way. The last thing I need to do is I need to go back to this idea where I had a hole at -2. And again, I'm looking at like x and y. And I need to say, okay, when x is -2, what's y? And I'm plugging in this -2 here, so it would be -5 over -6. So it's at 5, 6. So at the point 2 and then 5, 6, which is about right here, I just put a big old 0, a big old circle, saying that I have a hole there. This indicates the fact on your graph that we have a hole, that technically what happens right there, because of this and because it canceled out, it actually in that little spot, in that little instant, it doesn't exist, but it exists in other places. Now, please make sure to watch the next video, which is going to do another example of a graph like this, and we're going to be looking at slant asymptotes. Good luck.